Alright, hey guys, so we are talking through one-step equations with rational coefficients. That means that we're going to be doing equations, but with fractions and decimals in front of our variable. So, when you solve an equation, your goal is to get the variable alone. The variable is our x, our y, our letter or number or symbol that means what we don't know. We want it by itself on one side of the equation. In other words, you're trying to isolate the variable. You're going to hear that quite a bit. Now, when you are solving for a variable, you must use inverse operations to isolate the variable on one side of the equation. I like to say, instead of inverse, because it's a fancy word, I say undo. So, inverses that undo each other would be addition cancels subtraction, which means that subtraction cancels addition. Multiplication cancels division, which means division cancels multiplication. We also have to think of it like a balance. So I like to stand up and put my arms out like a balance looks like. And if I am holding one side of the equation in one hand and the other in the other hand, in order to keep it balanced, whatever I do to one side, I have to do to the other in order to keep it balanced. So if I'm looking at it like this, if I've got something in this hand and something in this hand, in order to keep it balanced, if I've got x on this side and 2 on this side, x and 2 are equal. If I take away that 2, I'm going to change the balance. So I would have to take away 2 from x as well. All right, let me show you what that looks like. So we've got 4.9 plus y equals -9. So we need to first identify, okay, what is happening to our variable, which our variable in this case is y. Well, right now I am adding 4.9. So I need to get rid of that 4.9. Let's zoom in here a little bit. All right, so I know if I go back up here and I look at, okay, what undoes addition? Subtraction. So if I go down here and I look, I'm going to say, okay, to get rid of this 4.9, I am going to subtract 4.9. But we got to think about it like a balance beam. So 4.9 minus 4.9, that is 0. So now I've got y by itself. But over here, I need to subtract 4.9 from -9. Here's the tricky part. If you don't think about this as a -9 and subtracting 4.9, you're going to end up with something like 5.1. All right? Actually, I think it's 4.1. But either way, we need to remember, if we've got a -9 subtracting 4.9, it is actually -9 plus -4.9. So we're going to add 9. I'm going to add a decimal 0 behind it, plus 4.9. I end up with 9 decimal. 9 plus 4, 9, 10, 11, 12, 13. So I end up with y equals -13.9, or 13 9/10. A big part of this is remembering your positive and your negative rules. So if you need to write it out as -9 minus 4.9 horizontally so that you remember your positives and your negatives, do it. And then rewrite it into your actual format to actually add or subtract. All right? Over here we've got x minus 17.1 equals -4.8. Okay? We got subtraction happening to our x. We need to isolate it by undoing that subtraction. So in order to undo subtraction, we do addition. So I'm going to draw my line to keep it balanced. I'm going to add 17.1, which -17.1 plus 17.1 is 0, so they cancel out. I got x by itself. But I also need to add 17.1 to my -4.8. Now, I wrote this horizontally to remind myself I've got a positive and a negative. If I have a positive and a negative, which are different signs, what do? I subtract and keep the sign of the bigger number. My kids will know, same sign, add and keep, different sign, subtract. Keep the sign of the bigger number, then you'll be exact. And yes, it is supposed to get stuck in your head. So, I have a positive 17.1 and a negative 4.8. So I'm going to subtract 4.8 from 17.1. I know my answer is going to be positive because 17 is larger. 1 can't subtract 8, so I have to borrow. This becomes 6. This becomes 11. 11 minus 8 is 3. Bring down that decimal. 6 minus 4 is 2. Bring down the 1. 12.3. So x is equal to 12 and 3/10. But what about if it is a multiplication or division? Again, we need to be very, very careful that we understand. I've got a variable here. What's happening to my variable? I'm multiplying it by negative 3. What is the opposite of multiplying by negative 3? Dividing by negative 3. I am going to write it as a fraction bar. Now, number one, I'm also going to keep my division. So if I have negative 3 divided by negative 3, a number divided by itself is 1. If I multiply anything by 1, it's the same. So that's what we want in order to cancel those 3's out and get C all by itself. But my balance is unequal. So if I divide by negative 3 on this side, I have to divide by negative 3 on this side. So I have 36 divided by negative 3. I'm going to tell you guys right now, I can't do that in my head. So I'm going to come over to the side and do some long division. I have a positive divided by a negative. Different signs means my answer has to be a negative. So I'm going to write that down so I don't forget. Now, 3 goes into 36. Let's look at this. 3 goes into 3 once. Subtract 3, left with 0. Bring down the 6. 3 goes into 6 twice, with nothing left over. So, C is equal to negative 12. What about over here? It looks like I have a fraction with m over 4. Well, if you looked over at this side, I showed my division by using a fraction bar. A lot of times you're going to see that fraction bar in our division problems. So I know it's m divided by 4 equals negative 50. So I'm trying to get m by itself. So I need to undo my division. How do I undo division? I multiply. So instead of dividing by 4, I'm going to multiply by 4. So if I multiply what is essentially 1/4 by 4 over 1, those cancel out, and I end up with m by itself. Now, if I multiply by 4 on one side, I have to do it to the other. I have a negative times a positive, so my answer has to be negative. And 50 times 4, I'm going to multiply. 0 times 4 is 0. 5 times 4 is 20. So, negative 50 multiplied by 4 is negative 200. Okay. You are very, very careful in paying attention to this. One of the biggest things that you need to remember is when you have decimals and you're adding or subtracting, you need to make sure to line them up. Okay? When you're working with negatives, make sure you're remembering those negative rules. Let's go to the back and let's look at this difficult one. We've got a fraction as our coefficient. So I've got negative 2/3 multiplied by d equals negative 6. So, Mrs. Coyle, how do I get rid of a fraction like this? Well, we talked about in order to divide fractions, we multiply by the reciprocal. So in order to get rid of this fraction, that's what we're going to do. We're going to multiply by the reciprocal of negative 2/3, which would be negative 3/2. But if I do it to one side, I must do it to the other. So this cancels, and we end up with just D. But then over here, I've got negative 6 multiplied by negative 3/2. How do I multiply a whole number by a fraction? I place it over 1. So now I can multiply straight across. 6 times 3 is 18. 1 times 2 is 2. A negative times a negative is a positive, so this is now a positive number. Now, I can simplify that. How many times does 2 go into 18? 9 times. Which means that our variable D is equal to 9. All right, I would like you to try your best on number 6, 7, and 8. Remember, we are doing the same thing. Right here, you've got 5/7, multiply by the reciprocal. Make sure you're paying attention to your decimals and your fractions and your signs. You guys are awesome. You're going to do great. I hope you have a great rest of your day. And to Mr. Chris's class, welcome to Mrs. Coyle's YouTube. Bye, guys.